का जो विषय है वो अत्यंत महत्वपूर्ण है। आज हम लोग चर्चा करेंगे बैलेंसिंग एनवायरमेंटल कंजर्वेशन एंड इकोनॉमिक डेवलपमेंट लैंड सुटेबिलिटी लैंड सुटेबिलिटी असेसमेंट। हम सभी ने महसूस किया है कि लैंड सुटेबिलिटी एक बहुत ही महत्वपूर्ण विषय है, जिसे आए दिन हमें कई सारी समस्याओं का सामना करना पड़ता है। तो निश्चित रूप से आज की ये चर्चा बहुत ही हमारे कामकाज के दृष्टिकोण से अत्यंत ही महत्वपूर्ण है। और इस विषय पर हमारे साथ चर्चा करने के लिए आमंत्रित हैं प्रोफेसर अश्विनी कुमार, जो सीनियर एसोसिएट प्रोफेसर हैं और प्रोग्राम चेयर हैं सेंटर फॉर एनवायरमेंटल प्लानिंग एंड टेक्नोलॉजी, यूनिवर्सिटी अहमदाबाद से। तो इस अवसर पर मैं आदरणीय अध्यक्ष महोदय, सदस्य सचिव महोदय और आप सभी जो भी हमारे कलीग्स और प्रतिभागी ऑफलाइन ऑनलाइन जुड़े हैं एवं हमारे जो गेस्ट रिसोर्स पर्सन है प्रोफेसर अश्विनी कुमार जी, उन सभी का अभिवादन करता हूं, स्वागत करता हूं और अनुरोध करना चाहता हूं परिषद के सदस्य सचिव महोदय श्री एस चंद्रशेखर जी से सर वो अपना
माननीय अध्यक्ष महोदय, बिहार राज्य प्रदूषण नियंत्रण परिषद, आज के हमारे मुख्य अतिथि एवं वक्ता श्री अश्विनी कुमार साहब, सीनियर एसोसिएट प्रोफेसर एंड प्रोग्राम चेयर इंफ्रास्ट्रक्चर सीईपीटी यूनिवर्सिटी अहमदाबाद, ऑनलाइन से जुड़े हुए हमारे व्यूअर्स और फिजिकली जो यहाँ उपस्थित हमारे साथीगण, आप सभी का मैं स्वागत करता हूँ। आज के इस समय में हम लोगों का जो है एनवायरमेंट और डेवलपमेंट को बैलेंस करना बहुत ही बड़ा चैलेंज है। कंट्री का इकोनॉमिक डेवलपमेंट का एम्बिशंस है, एस्पिरेशंस है मिलियंस ऑफ पीपल्स का, उसके ओर सरकार प्रतिदिन विभिन्न डेवलपमेंटल स्कीम्स का लॉन्च की जा रही है और पहले से भी बहुत सारे डेवलपमेंटल स्कीम्स चल भी रहा है, बहुत इंडस्ट्रीज का डेवलपमेंट हो रहे हैं। स्थिति में कैसे डेवलपमेंट को बनाए रखते हुए हम लोग एनवायरमेंट पर जो भी कुछ नेगेटिव इम्पैक्ट को कम कैसे किया जा सकता है, क्योंकि फॉर दैट मैटर कोई भी इंडस्ट्री या कोई डेवलपमेंट एक्टिविटी होगा जरूर एनवायरमेंट पर इम्पैक्ट पड़ेगा ही पड़ेगा। तो उसको देखते हुए उसको जुडिशियसली हम लोगों को ये एक डिसीजन लेने की जरूरत होती है। इसके लिए एक मैकेनिज्म क्रिएट किया मिनिस्ट्री ऑफ एनवायरमेंट फॉरेस्ट क्लाइमेट चेंज द्वारा इन द फॉर्म ऑफ स्टेट एनवायरमेंटल इम्पैक्ट असेसमेंट अथॉरिटीज, जिसके द्वारा एनवायरमेंटल क्लियरेंसेस दी जाती है डिफरेंट डेवलपमेंटल एक्टिविटीज पर। तो ये सब चीज बहुत ही अहम है हम लोग पर्यावरण को संरक्षित करने का और साथ साथ विकास होने का भी। आज ये बहुत ही महत्वपूर्ण दिन है। आज हम लोग का ये 11th लेक्चर है, मंथली साइंटिफिक इंटरेक्टिव सीरीज। सर ये एवरी मंथ हम लोग लास्ट थर्सडे मोस्टली वो जैसे अवेलेबल होते हैं टाइम स्लॉट, उसके अनुसार का हम लोग की जाती है। इसको ड्यूअल मोड में होते हैं। हम लोग का जो चीफ गेस्ट वक्ता होते हैं कि वो कभी फिजिकल भी अटेंड किए हुए हैं, ऑनलाइन भी अटेंड किए हुए हैं। अभी तक सर वो आईआईटी के प्रोफेसर, वो एनआईटी के प्रोफेसर, म्युनिसिपल कॉर्पोरेशन के रिटायर्ड सीनियर ऑफिशियल्स जो उनका अपना अनुभव बताते हैं। वैसे स्थिति में जो संबंधित विभाग को भी हम लोगों ने इन्फॉर्म करके सभी यूएलबीज के ऑफिसर्स भी अटेंड किए हैं। सभी स्टेक होल्डर डिपार्टमेंट्स इसमें इन्वॉल्व होते हैं। ये इसका मुख्य उद्देश्य प्रदूषण नियंत्रण परिषद का ये मुख्य उद्देश्य है, ये मंथली इंटरेक्टिव साइंटिफिक इंटरेक्टिव सीरीज करने का, कि जो मुद्दा अभी विश्व स्तर पर वो अभी बहुत अहम जो जिसका चर्चा में रहती है और नया कुछ रिसर्च हुआ है, आउटकम्स आया है, उसको आम आवाम को जो है जागरूक करने का था। विशेषकर जो अकेडमियाज के तरफ से होते हैं, रिसर्चर्स हैं, प्रोफेसर्स, टीचिंग फैकल्टीज होते हैं, स्टूडेंट्स होते हैं, उनको पर्यावरण के प्रति जागरूक करना और लेटेस्ट हैपनिंग्स अराउंड द वर्ल्ड के बारे में उनको बताना, ये इसका मुख्य उद्देश्य था। और इसका पूरा ब्रेन चाइल्ड डॉक्टर दीपंकर साहा साहब ने ही कंसीव किया था ये आइडिया, और हम लोग उसको कंटिन्यूसली विदाउट ब्रेक अभी चलते आ रही है सर. सर विद दिस फ्यू वर्ड्स ओवर टू डॉक्टर नवीन टू कैरी फॉरवर्ड प्लीज.
थैंक यू सर. थैंक यू
आप सभी को पुनः स्वागत.
Thank you for introducing the theme of today, and that is very topical.
Sir, Ashwini Kumar sir, we are happy to have you here amongst us. We are looking forward to hear you. Once again, I welcome you to deliver this lecture, sir. Now I hand over.
मुझे भी आने की बहुत खुशी है.
Yeah. Thank you so much, sir. आपने हम लोगों का आमंत्रण को आपने स्वीकार किया. बहुत बहुत धन्यवाद, sir.
मेरा खुद एक पॉल्यूशन कंट्रोल बोर्ड से बैकग्राउंड है. मैं डॉक्टर साहब और कोलीग, तो फॉर द पॉल्यूशन कंट्रोल बोर्ड आई एम ऑलवेज देयर. Rather I say that I am more with pollution control board helping hand and sitting outside rather than inside. Yeah.
So nice of you, sir. So nice.
It is very nice. It is very nice of you, sir. और प्रोफेसर अश्विनी कुमार जी तो एक डेविड रिसर्चर तो है ही है, एकेडमिशियन, और उन्होंने खुद ही बताया, मैं आपसे शेयर करने वाला था कि ही हैड एक्सपीरियंस ऑफ वर्किंग विद सेंट्रल पोल्यूशन कंट्रोल बोर्ड. तो एक तरह से वो हमारे परिवार के ही सदस्य हैं. तो इनके बारे में विशेष परिचय कराने के लिए मैं अनुरोध करना चाहता हूं हमारे कलीग श्री अरुण कुमार जी को, बोर्ड एनालिस्ट ऑफ दिस बोर्ड, टू प्लीज इंट्रोड्यूस दिस.
थैंक यू सर. श्री अरुण सर, आदरणीय अध्यक्ष महोदय, सचिव सर, बहुत खुशी है कि आज अश्विनी कुमार जी हम लोग के बीच हैं और बहुत ही महत्वपूर्ण टॉपिक पर जो है अपना लेक्चर देने वाले हैं. तो हमें जो कार्य मिला है थोड़ा सा इनके बारे में मैं जानकारी दे दूं आप लोग को. प्रोफेसर अश्विनी कुमार, a senior associate professor and program chair, urban infrastructure at Center for Environment Planning and Technology, CPET University, Ahmedabad. He is a renowned expert on sectoral environmental planning matters with a career spanning more than 25 years in central government, teaching, research and consultancy in domain of urban planning and civil environmental engineering. As an academician, he has been intensely involved in the strengthening and developing the modern perspective in the interdisciplinary subjects such as environmental impact assessment and appraisal, waste management, urban environmental planning and management, environmental infrastructure, environmental legislation, climate change resilience, and sanitation technology innovation. He is presently serving as a member of Expert Appraisal Committee on Infrastructure 2 at MOEFCC, New Delhi, and also a member of prestigious committee at Niti Aayog on Sustainable Hill Area Planning. His present interests are in environmental, social, and governance (ESG), water heritage, water-sensitive cities, and technology innovations in WAS. His earlier association with Central Pollution Control Board, Delhi, as environmental planning specialist engineer, has been on leading the term for implementation of sectoral environmental planning system under World Bank funded project and establishing the waste management regime. He was a team member of Asia URB's program, India Sri Lanka component, and received the UCNA Fellowship grant at TUD Delft, Netherlands. He served as environmental capacity building expert for ADB and World Bank training and is a research partner in many GIZ studies on climate change and urban waste management. He holds a Bachelor of Technology in Civil Engineering and Indian Institute of Technology, IIT Kanpur, and is a PhD scholar at IIT Bombay in integrated urban water resource management and water sustainability. तो आप लोगों ने देखा कि इनका एक काफी वास्ट एक्सपीरियंस है और बहुत सारे फील्ड में इन्होंने काम किया है। मैं इनका स्वागत करता हूँ। थैंक यू।
Thank you.
Yeah.
Thank you, Arunji. Now I would like to invite very humbly to Professor Ashwani Kumar ji to present his talk. Sir.
Namaskar. First, I would like to thank Bihar State Pollution Control Board, Chairman Saab, Member Secretary, Naveen ji, Arun ji, and especially Dr. Saha for bringing me on this forum. And this forum, as I learned from Dr. Saha, is going to be one of the very important discourse and the communication platform for public in general, environmentally interested people, as well as research scientists and the government agencies who are working. Thanks for inviting me in this conversation. As Arunji and Naveenji and Member Secretary Saab have already mentioned that land suitability, or you can say we generally call it as a spatial environmental planning as a broad term, are a few of the very important exercises or tools which can balance environment and development. I think before I start my presentation of PPT, I would also like to spell out that I started my career with the Center Pollution Control Board, and that too in a field of the spatial environmental planning. So that was a special activity under World Bank project, which has happened not only at the Center Pollution Control Board, rather it happened countrywide, where most of the Pollution Control Board have taken up some of the district and some of the locations to carry out a spatial environmental planning, including the Bihar Pollution Control Board. So thanks for inviting me and recalling the same discussion what we had and seeing its relevance even today. So you find its relevance is increasingly important now, because the pace of pace of the development is much faster, while the environment is still struggling to find its right or find its space in our overall economic or canvas. So I would share my PPT quickly. Is it visible?
Yes, sir. Yes, sir.
Is it okay now?
Yes. It's okay. Thank you. Yes.
So broadly, what I will do, I have divided my I've divided my whole presentation into the 4 different domains. One is to very briefly discuss about environmental conservation and development as a concept and the where we are struggling and why we are struggling to put both of them together. Then I think finding out some tools. So there is various ways and various methods have been evolved. Some of the methods which are more on the regulatory regime, while some of the methods which are more on the planning and the management regime. So some of the tools, we will discuss some of these tools, and then we will pick up the spatial environmental planning as a tool. And within that, the scientific exercise or scientific process, which is called as a land potential and suitability analysis. So this is going to be the flow of my quick presentation, and then I think we will have a conversation and settling its important more in today's context. So if we see in terms of the basic issue which arises in front of every one of us, an environmentally concerned person, is what is our human needs and where it goes into the greed. So we have the human needs certainly, but somewhere we started going into the human greed, and that is where we started conflicting with the nature. And if I try to put it further, if we see the very initial stage of our development as a human being, we were gather hunter. So that was a stage where environment has a much larger, while the human needs were much smaller. So if you see the arrows which are shown globally, we had so much environmental biodiversity in terms of the flora and fauna, water, everything was around us, while the human was a part of that. So our needs were very small, while we are having the several resources around us, and the natural processes, natural cycles our own cultural ethics and community regulations, they were the controlling factor on the human greed. So there was no greed existed that time. From there, when we moved to the second stage, when we started getting civilization, we started having the agriculture as a first of the economic activity, other than the hunting. The greed has started increasing, because as we started realizing that alternative to the nature's kandamul and animal, we can also survive our own by having the agriculture, and we can also the trade the agriculture produces, and that's where the greed started coming. So you can see the greed arrows are increasing, while the natural components are started decreasing. So that's a stage when we had a fire with us, we have domesticated the animal, we had agriculture, and we started building the human settlement, a small human settlement. When we reach to the third stage, which is we call it as the industrial development, basically in the West, which has happened, human needs actually started becoming the greed. So if we see in terms of the pressures on the environment have started increasing enormously, while the nature remained the same, or ever started getting diminished in terms of its capacity, in terms of its assimilative capacity, as well as in terms of overall availability. That's was the time when we had a very large cities, which have today become a mega cities. Many settlements came together, so we have a large expenses of the settlements. They clustered together. Industrialization started beginning. Transportation needs have increased, and for which we started expecting the fossil fuel, coal as a first one, then petroleum and the gas today. Then controlling factor started becoming more human made rather than the natural. So we had a protocols, we have a regulations, we have a national and the international standards, restrictions. And that is where I think we have such a high level of exploitation that we started getting many externalities coming out of the our activities. And this is a way world exists as today. So we have many pressures on the environment. Many environmental components have degraded. We see the pollution around us, air, water, soil, chemicals, waste from the cities and the settlements, industries, mining for the minerals, and many synthetic materials. They all have become part of our surrounding in the global environment today. So that's a stage now. Now question comes from here, how we can go to the next stage, and we may able to bring back the stage one, where though I think we'll not go back to the hunter gatherer, but on the other side, our environment should be flourishing again. And that's where we are here today to discuss, as well as many years we are discussing, almost 50-60 years we are discussing this whole issue of balancing the environment and conservation, environment and the development. And that is where the various domain of work have evolved. For example, environmental planning, where we plan everything suits to the local environment. Environment management, so we see that environment, that means air, water, soil, chemical, and land, everything is managed, optimized, use is optimized, and most efficiently exploitation or more expensive, more efficient use of that resource is done. And certainly certain components which cannot survive, which are fragile, need to be environmental conservation. So these all together may lead to the stage. If we work it out and we do it properly, then it may lead to the stage where we may able to say it, that we could able to balance the human need, and we could able to remove the greed, and that's where the balance is achieved in terms of need and the environment. So that's what is a desired level. But as of now, we are struggling to put all these domains, whether it is environmental planning, management, or conservation, or environmental regulation, together and in tandem, so that we are able to achieve something. So that's I think first conceptually where we are today, and where we have gone wrong in a way, or we didn't realize that what's happening, and that's where we are. Now from here, if we try to see the stage, where or some of the tools through which today we are trying to balance it out. As I mentioned, environmental planning, environmental management, environmental regulation, or conservation could be the way. So there is a various tools people have tried to use it. One of the tool is called as a spatial environmental planning, because if we see, everything happens over the space. So whether it is a development or whether it is a environment resources, they all spread over the space. So that's a reason that is a spatial environmental planning is one of the tool which can be utilized positively. We also have smart city. Today we are talking about a smart city. so that our systems, urban systems, is basically become such a efficient, reach to the such a efficient level that exploitation of resource is minimized. We can have a just required resources at our end, and we don't waste the resources. That's a concept of the smart city. So there's a many component within the smart city, whether it is a smart waste management, smart water supply, using the digital technologies, smart way of treating and reuse, recycle of the wastewater coming from the cities, and many such things are there. Another thing, another tool which is, I think, more toward the regulated side and policy side of the any country, which is on the environmental conservation. So every country has their own policy and the regulations so that environmental conservation is done. We also have the Forest Act to conserve and protect the forest as a one of the biodiversity. Similarly, we also have the Coastal Zone Regulation Act so that we can manage the coastal areas, and many such kind of act regulations we have. Also, I think recently with a kind of huge funding which is coming from the international agencies as well as the national government, there is a evolution of a framework, or in a way a kind of guidelines which is called as a environmental and social management framework. So these are the also evolving today as a one of the tool through which we can manage and improve the environmental situation while the development is also happening. So there are many more tools, but I have just brought in few of them which are relevant and which are near to our own domain. So within this tool, what I picked up for the today discussion is first one, which is spatial environmental planning. And we may get that time later on to pick up the other tools to go ahead further. So if we pick up the spatial environmental planning tool, and its root, the root of a spatial planning tool also goes into the global sustainable development agenda that's called as the Agenda 21, which came out of the UN conference 1972. By examining this particular agenda says by examining uses of the land in an integrated manner, it makes it possible to minimize conflict. And that is what we are talking about. We are trying to balance environmental conservation and development in a way that we assess the land such that we remove the conflicts and we make a most efficient trade-off. So these trade-offs between the development and between the environment is also achieved. And we also achieve the social and the economic development with environmental protection. So that overall agenda of sustainable development is actually inherently lies in terms of the spatial environmental planning. This spatial environmental planning also coordinates between the various sectoral planning. So if we talk about the sectoral planning, we have a different sectors in our economy. So if we talk about economy, we have agriculture as sector, we have infrastructure as a sector, we have industries as a sector, we have within the industry, there are many type of industries. And if we see also in terms of we urban as a one of the another sector, so there are many sectors which need to be planned. But if we try to plan all of them in an integrated way and looking their implications on the space, that's conceptualized as a spatial environmental planning under the Agenda 21, UN's Agenda 21. So with this background or this support which exists as a global policy and global concept, the spatial environmental planning tries to look in terms of something which is what we don't have today. Today, if we see in terms of the country, we lack the spatial plans. So if we talk about this, many cities, their master plans or development plans either have expired or they are pretty old. So there is a gap. So there is no legal master plan exists on today. Many places it happens. So we don't need master plans only for the cities. We also need a master plan at a regional level. We need it at a state level and national level. Though scale and the type of these master plans do change, but there is a need so that all these different levels of plan discuss or integrate among themselves. For example, if we take a national level plan in terms of the Ganga River, which is exists in half of the almost 40% of the landmass of the country. So if Ganga River is planned in some way with a perspective of the future, that fits into the each state what they have to do. The state will also have their own water related plans. And when the states have their plan, then certainly there are smaller regions and smaller streams, as well as all the cities and towns located along the rivers will have also their plan, which are aligned together. So then only we can able to achieve kind of what we intend to achieve under the Ganga Ganga River plan as such. So that's where the integration comes in. So on the other side, we have lot of development which is happening, but it is unbalanced. Some of the sectors or some of the aspects are very fast, while some of the other sectors are not at all that fast. So if we see the population increase in a cities is happening at a very phenomenal and very high rate, and we expect by 2050 India will have 50% population living in a cities. That means around 800 million people will be living into the large cities and small cities. As compared to today, in 2022, we have around 37% of the population, which constitute around the 400 million. So from the 400 or 450 million people, we will be reaching to the 800 million people in next 20 years. So whatever has happened in last 150 years, going to happen in next 20 years. So that high level of influx of the people in cities is certainly going to create an imbalance in terms of the exploitation of the natural resources such as water, land, soil, and many areas which may have become the surfaced area. We also have given the target for the economic and industrial development, but we have very rarely have given target for environmental improvements. So these targets in terms of measurable, monitorable, as well as something very actionable, these kind of targets are not there. Every state, every place, we have a very good policies, but in terms of targets, we do not have. As compared to that, in economic and the industrial sectors, we do have targets. Even if somebody tries to take a target and take it forward, we do lack many guidelines. So we do not have guidelines how to go about in terms of environmental conservation, environmental protection, and environmental management in any of the sector. And we still need a lot of professionals and a lot of input from the experts in this sector. Now coming to the actual aspect, which is called as a spatial environmental planning, which attempts to bring all the four aspects together, whether it is social and demographic, that means population, which needs resource exploitation, economic aspects, which set up the goal, whether we need an industry at a location, whether we carry out a mining, tourism, and what need to be done. Environmental aspects, flora, fauna, resources, pollution, all this comes together, and land. Land as one of the basic resources, because every activity of human being needs land. So that's why the spatial environmental planning, which try to optimize all of them, resolve the conflict, and guide them to the right appropriate places in over the space that where what activity can be carried out. So basic concept of spatial environmental planning lies in terms of resolving the conflict. So there is a one side which is a polluter, or there is a pollution, and there is a potential threat coming from the certain activities of the human being. On the other side, there are natural resources or the human beings which need to be protected, which need to be conserved. Both of these two have to be relatively located to near or the far away from the each other, depending on whether they are compatible or whether they are conflicting. So this is basic essence of spatial environmental planning, and which is logical, scientific, as well as measurable on a ground. So one can go and find out where what has been suggested and where what can be done. So this is a basic concept to put two of the domain, segregate them, and give them the right places for each one of them, and let them survive of their own spaces and flourish. So that's a basic concept of spatial environmental planning. More in terms of measurable way or application of this concept, it can be many. So it is not as if that we are resolving conflict with the industries only. There's a many different levels and many different ways such kind of environmental planning is a spatial environmental planning can be carried out. So it's the application where I have been personally involved in all these levels, and these pictures what I'm showing it. So one can look into the regional as well as district level plans and then can resolve the issues. Here we look into the ecological resources such as forest, water bodies, large lakes, as well as kind of sensitive zones, which may be wildlife, which may be national park and things like that. So, or even the hills and undulating places and the natural landscape. So this is what becomes a major resources need to be protected and conserved at the regional level. The same tool can be applied to achieve the sustainable development plans for the cities and towns. The case is Guwahati here. Probably we will get time to discuss this Guwahati case as well. So one can evaluate city and find out which which part of the city can be promoted for the intense development, multi-story development, or which part of the city should be promoted for the low level development. So that's how it can be done. The recent global discussion on the climate change mitigation adaptation plan can also take help of the spatial planning and generate many scenarios and take a decision. So this is a case where micro level work has been done at Naroda, one of the small industrial estates in Ahmedabad itself, and where you can see the flood mapping or flood scenarios for the future has been generated with an increased temperature, how flood will affect the industrial estate. So that kind of assessment is also possible. I may have some slides on this one to discuss. Then on the sector basis we talk about, we can have the spatial order planning for agriculture areas. So one can identify the lands which are best suited for the agriculture promotion, and we can reserve those lands for the agriculture. This also helps to achieve the food security in a region and the country as a whole. One can apply the same tool of spatial order planning for industrial development, making the plans for the cities, the plan for the districts and the region where what kind of industries are possible, looking into the many criteria together. This is one of the district in Gujarat, where I have been personally involved while working with the Center Pollution Control in terms of carrying out a industrial siting exercise known as a zoning atlas. Same exercise or same spatial environmental planning at least can identify very easily which are the places and which are the regions having the good environmental resources. So at least these mapping and identifying such resources itself can help us in making the conservation plan. So one can use the spatial environmental planning to make a conservation plan as well. Now, all these activities have a one basic component behind it, which is called as a land suitability analysis. So every of this activity actually try to evaluate the land in terms of set up the criteria. These criteria may vary depending on which application we are choosing. So if we are choosing the urban applications, it may be very different as compared to if we choose a climate change related application. So though criteria will keep on changing, but basic concept is we evaluate land and the region based on multiple criteria. So this exercise or this tool, which is scientific and which is a logical tool, is called as the land suitability analysis. Here as a name itself indicate, land, when we say land, doesn't mean only its surface. It includes the ground, that means including the groundwater. It includes the soil. It can be also in terms of your landscape. So land includes all these things which are happening on the land. Second key word, which is suitability. When we talk about suitability, the suitability is from the perspective of a certain use. As I was mentioning that if we want to use this tool for the urban, then suitability criteria are chosen accordingly. So suitability keeps on changing depending on region, location, and local regulations. So that's how the suitability comes in. And when we say analysis, means it is able to put all of them together, and not only together in terms of some numbering, because we are using space and we are using maps. So it is able to carry out logical spatial analysis or spatial operations. Such operations which is called as, for example, overlay. So when we overlay two of the maps, we may start getting a very different perspective than each of the map is telling of its own. This I think we will realize once we go ahead through the cases, some of them. So formally, the definition which was given by some of the researchers says the land suitability analysis is a process of understanding and classifying the nature or the quality of land on its component parts. Component parts means whether soil, whether it is a landscape or something else, based on the ability to serve a particular use or the purpose. So first we decide about the use and purpose, then we start looking into the its criteria, and then we comes to the part. So in a way, it is a multi-criteria analysis. So there is a multiple criteria, and that's hence it is called in a multi-criteria analysis to achieve certain kind of decisions. So this is a decision-making tools which help in us in achieving something. If we try to see in terms of some terminology, So as I'm mentioning again, it's a criteria. So criteria could be, for example, a land can have a criteria as a slope, can have a criteria as a soil quality, can have a criteria in terms of the groundwater availability, depth, or groundwater quality. So there can be many criteria one can choose in. Relative score and weightages. So when we are putting many criteria together, we have to choose which of the criteria are more important from our perspective and which of the criteria are slightly less important. So that's how we need a scores and we need a weightage. So that's both are required, and one can make a system or the hierarchy of such scores and ranking. So these scores or ranking can be ordinal, linear, or the logical. So it can be yes and no, that means exist or doesn't exist at a location. Linear, exist, but slightly less or slightly more. Or it can be exactly like a slope is a linear. So slope can be 1.5 degree, it can be 2 degree, it can be 10 degree, it can be 50 degree. So that's a linear. Ordinal, if it is more, less, or medium. So high, medium, and low. So many things we can divide as a high, medium, and low. So as if we compare, for example, water quality in terms of many parameters, we can conclude water quality is fit, unfit, and less fit in a way, or need to be improved. So there can be ordinal scales as well. And these all scales or these whole system is arranged in a AHP using the AHP analytical hierarchical process. And that's where we use a yes, no, knockout, or collecting them together to achieve certain output. This I think we will see through the cases, few of the cases quickly. So we see in terms of stepwise approach of land suitability analysis. So first step is to identify the land uses or create a land use inventory. So we may select an area, then we try to find out the land uses, but it is one very important to have a scale in a mind. So if we are looking into the urban scale, the land uses will be, for example, commercial, would be in terms of your public utilities, in terms of residential. But if scale is district level, then there is no commercial. It all is a developed area. This all is becomes a settlement, part of the settlement. So settlement, agriculture, forest, water bodies, that may be the kind of land uses. So depending on the scale on which we are working, the land use inventory is prepared accordingly. And then we also understand that for the defined purpose, so if we are carrying out exercise for industrial purpose or the urban land or urban development potential, then we identify which of the land use is most suitable and which of the land use is less suitable. And that's step number 3. And that is based on the certain factors. So if I say the particular land is more suitable for urban development, so what could be the natural factors which compels me or which promotes me to saying like this? It could be, for example, the land should be the flat land. That means slope should be near 0 or maximum up to certain degree. We can think of and we can decide up to 5 degree or 6 degree, 10 degree. So that is one of the factor. The land should be relatively near to access or have a good access. That means already existing places and the places which are not very difficult to access naturally can be promoted for the urban development. So likewise, one can keep on selecting the factors which they choose most suit to their purpose. And that is where we try to map. That is a step 5. So when we say I have chosen the slope as one of the criteria, now I will map this particular criteria into the detailed manner. So I will prepare a map having the slope 5 degree, 10 degree, 15 degree, 20 degree, 30 degree, likewise. So that is a detailed phenomena which has been mapped. Now, from this suitability, so gradient of suitability. So if I selected slope as one of the criteria, so and when I'm doing in the hilly region where slopes are varying a lot, so I can make a kind of suitability gradient, and I will decide that my settlement can be located up to the 10 degree of the slope. So that's a gradient. I have decided a gradient and combination saying that 10 degree is what I have decided. That also put a kind of me in a situation where in step 7, I identify constraints between the potential land use and the processes which are happening around. And once I put all these opportunities and the constraint together in the overlays of map, I started getting output. I started finding out multiple criteria perspective, which is the land which is suitable. A land which is suitable from the slope point of view, it is a flat land. Groundwater is also not very deep, so that's also is appearing. So those two combinations come together. Third could be away from the forest, that also comes together. So as many overlays map I use it, that many factors I am accommodating in my perspective. So collecting all this as a composite map. So finally I get a map which says a piece of land which is flat, which is away from forest, which is also having near to the groundwater and probably near to the other water bodies. So then I get that particular piece of land identified automatically using the capability of the computer and automation. And I say that, okay, this is the land best suited one. But only that land is best suited. What about the other lands? And hence this suitability becomes kind of graded. So highly suitable or highest suitability, then a very high suitability, medium, moderate, low, very low, and not at all suitable. So there is a various gradient or various grades of suitability are generated out of this. So this is purely in terms of the theory and the process as a steps. So this is also shown, for example, just to quickly conclude in terms of the clarifying the steps. For example, I have chosen agriculture purpose, and I want to what the agriculture needs. It needs a water, it needs some flat land, it needs some many other things together. So if I've chosen purpose is agriculture, what I will see that for that agriculture, what should be the physiography is needed. What is the kind of soil we need it? What is the kind of hydrology we need it? What is the kind of climate I need it? And wildlife and other situations. So this all natural factor are get accommodated in a kind of listing here. So even if the land is having the flat, but does it have a soil of that kind? Does it have a hydrology of that kind? Then only it becomes suitable for agriculture purpose. Once that is done, so among these, if I look into the factor which is physiography, that means slope. So then this is a gradient, what I mean to say, gradient of that particular phenomenon. So I may look into the slope 0 to 3, 3 to 8, 8 to 15, 15 to 25, more than 25. So these are all the gradient. Here, there's a cross is marked, that means that land is suitable. So I can say 0 to 3 is the best suitable, but 3 to 8 is still okay. I can work with that. But more than 15, I cannot work. So the lands which are more than 15-degree slope, 15% slope, are not suitable for the agriculture purpose. So that's how I take a decision on that. And then these decisions are put together. At the same time, we also have a constraint. So opportunity instead of constraint, for example, agriculture, there can be a constraint of fault zone, there can be a constraint of regular flood areas. So these are knocked out. So I cannot have agriculture where floods are happening very frequently. Or there's a fault zones where I cannot have a residential or the city developed there, because that can lead to the earthquake prone vulnerability. So that is a step. The last three steps are actually exercises where you overlay, you decide about the criteria, you put some kind of thing like a buffering. So if you want to keep people away few kilometers from the forest, so you will take a forest and you will create a buffer around that. So these are exercises which are spatial analysis exercise which one can carry out. Possible applications are many, so I will discuss some of them. For example, one of the application where agriculture use is talked about, and FAO has given the definition. So FAO has given a definition which of the land is best suited for what purpose. So this can be very meticulously can be worked out, and people have worked it. For example, using the similar kind of criteria, there is a USDA classification of agriculture, class 1, 2, 3, 4, and 5, 6. So here, first two classes are actually useful land for agriculture. Rest of the classes of the land is not suitable for very good quality of agriculture. Okay, that means class 3 or class 4, 5, 6, 7, 8. These all lands are suitable for any other development. So if we want to locate the industry, they are best suited for these classes, unless until the physical conditions are start becoming unsuitable. So for example, the last two classes are having some kind of physical constraints. There's a undulating, there's a rocky situation and things like that. So then it is difficult to construct. Otherwise, class 5 and 6 are good for the industrial development as such. People have tried to create an indexing system using the similar kind of exercise, land suitability analysis. I will skip this one. I will come to the places where we have worked. As a pollution control board, I think industries and sometimes guiding to the industry to right location becomes our kind of policy or becomes our kind of perspective. At this juncture or this point, Center Pollution Control Board way back in mid 90s have taken up exercise called as a zoning atlas. I have a separate presentation of detailed on the zoning atlas. If the group later on thinks, I can discuss on this. But very briefly, this whole exercise was carried out around 200 districts of the country. And these places, all this exercise was carried out at 200 places with the help of the state pollution control boards, where multiple criteria analysis have been applied and mapping has been done for the resources. And this includes, this whole methodology includes like this. So if you can see my cursor on the left-hand side, most left-hand side, you see the reference map, village reference map, and base map. These village reference map was one of the unique map which was printed at that time on the transparency. So we didn't have way to overlay. Today we have a computer capabilities where one can overlay automatically, but that time we didn't have. So this was printed on the transparency. So one can take out transparency, can put on any of the map and knows the village name. So if end of that, if you have identified a land which is suitable for industries development, one can find out by putting the village map on top of that map, which village the person should go and buy the land. So that helps the industrialists to buy land at a suitable places. Other than that, these are the basic mapping which was done for every district level. And that is, for example, land use map. And these all were created, one is to 250,000 scale. That means 1 centimeter is almost 2.5 kilometer on the ground. So then physiography map, which to talk about a slope, what wasteland map. So every district there's a wasteland board. Wasteland board gives a wasteland map. So those maps have been used because wastelands are the best suited site for industrial development. So if we have a wasteland available and that is suitable for multiple purpose, it can be used for industrial development. Similarly, like a drainage map, irrigation map, agriculture map, and existing industries. So if there's some industries already existing, we can increase number of industries around that. Then many of the sensitive zones in a district. For example, we may have a national park. Hello?
Yes, sir.
Hello? I'm audible. Okay.
Yes,
Fine.
sir. Yeah. Go ahead.
Yeah. The screen was still, so I was got confused. So we created a sensitive zone which include the national park and sanctuaries, which also include the tribal settlements, religious centers, monument, and flood prone areas, because all these are the sensitive and they generally are avoided for the development. The whole analysis or whole you can say whole logical arrangement of the land suitability was also included 3 of the important environmental factors: air pollution, surface water pollution, and groundwater pollution. So the basic concept, I think, though there are many of the map, but basic concept of the air pollution sensitivity was that certain spaces in a district are good enough which can disperse air very easily. So even if we create a bit air pollution there, it is not going to be locked in, it is going to be dispersed. And that is where we have a dispersion sensitivity map, which looks into that how the environment, and in a way that we used to discuss about the assimilative capacity. So those areas are having better assimilative capacity as compared to the other places where probably air may be locked in. So that's what one of the way it was assessed. Similarly, for the surface water pollution, if there is a places where water flow are very good and water quality is also very good, that need to be conserved as such. At the places where flow is very high, that means even if we are putting up some small pollution in that particular water, it can be quickly mixed and can dilute it. As compared to the other places where even if you are putting a small pollution, but whole stagnated water is there or very slow moving water is there, then it is not going to spread very fast and create a more toxic environment at that local space. In case of the groundwater, the concept was that groundwater can be polluted by having depending on the nature of soil. So if soil has a very high infiltration rate, any pollution on top of the soil can quickly lead to the groundwater. So that means those spaces wherever the infiltration rate is very high cannot be used for dumping of the waste. So because if you dump the waste on top of that, any leachate of any small of the amount of the leachate can go down. Now, in a way like this also accommodates the technological options. So one can say that I can make my industry which does not emit any air pollution. That means zero air emission or zero discharge. So that also accommodates this one, the potential of the industries to pollute, and nature, potential of the nature to assimilate it. So these are the two things together to logically conclude the areas where what kind of industries can be allowed. As a final output, this is what we get it, end of that. So this is one of the district in Gujarat, Panchmahal district. District has many forests or many agricultural land, which all is accommodated in the white spaces, if you can see. And if you see in terms of the colored spaces, each of the colored space is not less than, for example, 100 hectare or something of that scale. And each of the space, colored space is suitable or not suitable for certain kind of industry. So we say blue colored spaces, it says all water polluting industries. So these spaces are good for the industrial estates or the large industries such as pharma, chemical and things like that, because these are the places where very high assimilative capacity exists due to the natural water flowing around that. Similarly, if you see yellow color one, it says or air polluting industries, because these are the places where air dispersion is very high and none of the air is going to be getting stuck at the local places. So that's how this was assessed further. So this is how the industrial application of SCP has been done. I can show you that some of the district level applications quickly. I think, do I have a 5 minute more? Arun sir or Naveen sir?
Yes, sir. Yes, sir.
Oh,
You may
fine.
continue.
Yeah, I have many cases. So though I started with industrial cases as my basic experience, but then once I came here at SEPT University, I started applying same concept in many other applications. So if you look into the district level land use planning, this can be again done. So this is the Surendranagar district. So the way we have looked, the district also have a sensitive zones. The same way we have evaluated sensitive zone for the industrial purpose, we also mapped all the sensitive zones for the district for the urban development and many other purposes altogether. So this shows small green spots which are a forest. So small forests which are reserve forest or the protected forest planted by the state government as such. Also, if you see this as one of the continuous stretch of the green, this was border plantation, which was done under the anti-desertification schemes of the government of India. So since this has been done, this also need to be protected. We cannot now allow it to get degraded. The pink color spread is actually the hilly region, though I think in general district is flat, but some of the hills exist and they flow like this. So that all is mapped and together called as a sensitive zones. Along with that, there's a Ramsar site. This is a Nal Sarovar site, is one of the bird sanctuary out here. So that's all is mapped. And then I think finally the district has been evaluated in terms of the agriculture potential and agriculture conservation areas. So this is where the blue color areas are having the highest potential. Reason being because this is likely to, this is now today it is almost covered under the Narmada Canal. So if the Narmada Canal is coming, we should promote that area maximum under the agriculture rather than anything else. So that's how it comes in. You can see that different smaller towns. So we have allocated certain areas around the town with different potentials of development. And these are the connectivity. The broader the connectivity, more higher the potential. That line which you are seeing on the right side of the map are the fault lines. So here important to see, if you see the one of the small town known as a Vadwan or the district headquarter is actually sitting next to two of the fault line. So if the town grows on the direction of the fault line, it may be one of the critical stage and vulnerability at the time of earthquake. So we generally suggest that the towns should be developed on the other side, to not be allowed to develop on this side. So that's the kind of assessment output. Similarly, for the urban development suitability, so these all are the non-agriculture, which includes your cities and kind of industries. So what type of land is suitable, what kind of urbanization is possible, and what kind of amenities are there. So these all lands have been evaluated from that perspective. We also tried to check that existing industrial development happen in the same district. Where does it? So some of the development actually happen in agriculture areas, and some of the development has been happen in the hilly region. So both are not right one. There could have been much better places where it could be developed. The other exercise where I've been involved is a kind of regional plan. So this is a Baddi Barotiwala area where everyone knows that many industries have established under the uh, tax exemption scheme of the 7 year starting from 2006 and 7. So this is a kind of space, you can say haphazard development, different levels or different heights, but industries are at top and your towns are at below. So there's, I think, quite difficult situation. Many places, industries stack is emitting the smoke just in front of the houses or just in front of the windows of the houses. That's kind of situation out there. And while the good quality housing, or you can say modern housing, is also coming up, and large industrial development is taking shape. So this is what is in the Baddi Barotiwala area of the land use before our plan has been done. The same, the land has been evaluated using the many criteria, but basic criteria at the very large and district level were water bodies. So all the water bodies and drainage have been, you can say, evaluated, and areas identified where it should be protected, and rest of the area where minor drainages exist, they can be developed. Similarly, in terms of the forest, so the area has certain forest which needs to be given buffer. So there is a buffer given. Similarly, slopes and elevation. These all criteria have gone together to create a map which is called as suitability. So we have an environment suitability map. So it says that only this light color area is suitable and dark color area is actually not suitable much. While the potential, if we look into the potential side of that, which looks into the land prices, it looks into the already existing facilities and development, that says that two of these stretches which are more suitable. So when we put this and this together, actually we could able to identify area which can be open up for development, and also identify the area which should not be open up for the development. So with this basic input or this support, we took it further and created a regional master plan. Basically, if you see in terms of this map, so all the light colored area only has been shown as bit in terms of the yellow and development. So yellow area, which is distinctly yellow out here, is actually the bit developed area in future, but we have not allowed industries, etc., to grow further because of fragility of the area. So this is a different way. Similarly, we also work for the Guwahati, where crucial thing is like this. So we see the city has Brahmaputra river grown like anything. So today, many areas which are under flood and the critical situation. So this is what the city looks like. So there's a Brahmaputra river. So if we see the flood near to that river zone, then there's a high development, and then we also have the hills and natural environment. So city is mix of everything. So what we have done, similar kind, and city faces severe floods. So if you see the situation, every year there's a flood in many parts of the city. So city is like this, river flows out, and this is where the city is spread in, many hills are there, and it's like a bowl shape. So whenever there's a flood happens, city get inundated. So that's a kind of situation city has. So this we have analyzed it again, looking into the forest and the hills, water bodies, and there's a large wheel, or they call it as a kind of lake. So this is how the evaluation has been done. Slope, again, water bodies, seismic map, because this is northeast. So we also took the seismic map as a one of the criteria, and reserve forest. So based on this, we have identified the hills which should not be allowed to develop. Otherwise, at present, there is a large scale encroachment happening along this kind of hills. And then we compare the existing development plan and how does it promote it. So this is what is a suitability map says, and this is how the plan talks about. So if we see in many places, like for example, this city says we can have institutional area, but here if you say, for example, this area which should not be developed much. So that's where the difference comes in this, as well as the decision they have taken. So with this kind of analysis, what the conclusion we could arrive in today's discussion is spatial environmental planning provide a lot of possibility of protecting the environmental features, be it forest, be it water bodies, national parks, any sensitive zones, even the hazard prone areas. So it provides protection of the environmental feature and also creates a safe environment. Spatial environmental planning also recognize the need of economic development and guides it. It does not say that I will not give you the land. It says that, okay, I will identify land for you, which best suited for your purpose. So it guides it to the right places. SEP is flexible. So generally we see that, okay, SEP or spatial environment planning has defined a land at like this, and I cannot use it for that purpose. It says, yes, if you change your technology, if you can change the nature of your development, you can come here. It doesn't say you cannot come here. It says, yes, you have to make your life suitable for environment. And that's why I think the motto is that this year, where you say life for the climate suitability or suitable lifestyle, what we need to inculcate. As a part of land suitability analysis is a logical and scientific process. It is not just a map. It converts our understanding into map, and then map plays with each other to give us right output. So that's, I think, the LSA. LSA saves a lot of time in development planning. Otherwise, in terms of the survey, collecting the data, going, checking on the ground, takes a lot of time. And because of that time is not available, either people take a decision on the desk, which many times goes wrong as such. So that's, I think, special land suitability analysis do allow to do carry out the work quickly. A land suitability analysis also provides input to make appropriate choices. So it provides input where what kind of land use can be developed. Land suitability analysis also promotes, and it also takes into account the technology development and which can change criteria. So if we have a technology which can withstand the slope, which can withstand the very near to the groundwater, very near to your foundations, one can change the perspective of that criteria, and it can be from the unsuitable, it can be suitable with that kind of technology. But the only point what is there, that since spatial environmental planning and the land suitability analysis is not appearing any of the institutional or the legislative or any of the policy act or regulation, it is generally, or you can say mostly, it is being not taken into account whenever there is a development plan is prepared. Though I think URDPFI guideline, which is national level urban development guidelines, it mentions the land suitability analysis, as well as we as a academic institute and professional and worked in both the domain of environment and planning. Wherever we do our work, we make it sure that land suitability analysis becomes an inherent part of the work. It does not remain outside of our work. So I stop here, and I will take the questions and the comments from the August gathering. Thanks a lot.
Thank you, sir. Thank you for the nice presentation. Now I would like to request participants, if you have any questions or queries or suggestions, you are most welcome. Yes, sir.
Actually, good presentation. It's a recapitulation for a long pause of time. I just wanted a small query. US, you have talked about the land classification in US and URDP. What is the difference between these two? And the land classification, if applicable in Indian condition? So that is also important, because the metrology is the guiding part for management of any soil also, including soil erosion, water stagnation, water flow, river flow, flood, etc. And if you are comparing the land suitability criteria from US, how far it is applicable in Indian condition? This is number one. And number two, since I am associated with Bihar nowadays, so if you have some case studies for us, that will be useful for us. Thank you.
Yes, thank you, Dr. Saha. I think both of the questions are very relevant. The question one, which talks about what kind of land evaluation systems country should follow. So what system what I'm shown is a kind of generic system developed by the USDA, US Department of Agriculture. Based on that system, Indian Agriculture Department or Indian Department of Agriculture adopted the same system to be followed in India. So when they are carrying out the exercise at a very, very broad level, then at that early stages, I'm talking about like when we had a green revolution, and that time when huge input was there in agriculture sector, that time they adopted the same system which was there in US. So in their system, they do not give a conclusion in terms of value of a parameter, but rather they mention the existence or the non-existence of those parameters. For example, they say that if an area which has severe in terms of the erosion. So that's how they mention that erosion is a constraint on agriculture. So if there's a high erosion is happening at a location, over the period, this land is going to be lost and we cannot carry out agriculture. But what should be the severity? A country has to decide. So that is the reason they have not given the value to that criteria, but they have mentioned this is an important criteria. So they have mentioned slope is an important criteria, but how much slope agriculture should be done, that is up to the country and even to the state. So if we go to the hilly places, they carry out agriculture even at a level of something like a 20 to 30 degree. While if come to the Gangetic plain, we will not carry out agriculture more than 15 degree. So that varies. So that's a answer to the question number 1. Question number 2, in terms of some exercise and cases to the Bihar. So I would request that you take up exercise and I am available to share my expertise and guidance to your team. And rather you can develop a team at the Bihar State Pollution Control Board who accommodates local understanding and brings our expertise into that one. So you can carry out this exercise. For example, Gujarat State, way back when we are carrying out the zoning atlas exercise, we funded only, I think, 3 or 4 districts, but Gujarat has carried out exercise for all 19 districts. So today, the Gujarat Industries Department, not only you can say Environment Department, their Industries Department is keeping all those maps in digital form. So whenever there's an entrepreneur comes and asks that in this location or this districts, I want certain lands to be purchased of this size, this Industries Department can suggest easily that these are the wasteland, go and buy in these villages. So that same concept they have expanded to whole state. So that's depends that how the states are taking it forward. I see and I request if Bihar can also take it forward. It's, I think, is a very useful for the Bihar. Will be very useful. Yeah, thanks.
Thank you, sir. If I remember right, in those days, in the zoning atlas project, spatial environmental planning, we had done zoning atlas studies or this planning exercise for 2 districts, that is East and West Singhbhum.
Yeah, that's right. I was forgetting the name, but Jamshed and industrial state planning for Jamshedpur. In Jamshedpur, I think that time we did. Yeah.
इसमें सर यही किया था और पटना किया था सर, 2 डिस्ट्रिक्ट का पब्लिश, और उसका सर वो पब्लिश भी किया, वो पब्लिश लॉन्च भी किया. लेकिन ये है सर कि उसका यूसेज unless and until it is included in the some framework, some legal mechanism में, because when you decide a project, industrial project, then there should be a mechanism, legislative mechanism, that findings are incorporated in the system. Otherwise, sir, वो academic exercise होके रह जाता है. तो यहाँ भी वही हुआ सर, with due permission, कि वो report तो जरूर हमने बनाया, maps बनाए, लेकिन उसका जो intended use था वो शायद नहीं हो पाया.
लीगल प्रॉब्लम में फंस गया था, इसीलिए नहीं हो पाया.
Actually, as of now, since the time EIA notification was notified, the very purpose of creating the expert appraisal committee was to look into all these parameters, right?
It's very helpful.
If someone is want to locate an industry at a particular area at a particular point, this is what the environmental expert appraisal committee looks into. Actually, so
exactly.
There is no explicit mention about this in the EIA notification.
Yes, sir.
But it is for the experts to look into all these things, like our own today's resource person, Chief Guest Shri Ashwini Kumar. He is also a member in the expert appraisal committee. That's the reason why these sort of experts are included as one of the.
I will give you the example of this one quickly. When I think since you have mentioned this appraisal committee, in one of the cases, I think while we were talking about, then I think since now I think all this spatial information to some way is available on the Google Maps. So we very often go to the Google Map, and I started making that as a kind of habit. Then whenever there's a presentation, I will search to the site and things happening around. And many times we had an input from those Google Maps, which I think compelled the project proponent to correct their own understanding about an area. So that's, I think, is a reality. I think if this kind of maps from your own purpose are printed in a way like they are available to your own state level committee, I think that their decision will be much faster and much appropriate and related to the ground. That's I think is a fact. And as I'm mentioning, the Gujarat state has anchored this exercise, spread all over the state, and used this map in a digital form and kept it with the Department of Industries and Industrial Promotion. So they have taken it positively. Rather than saying that industry should not come at this location, they started saying, if you want to buy something, come to us. We will tell you where you can buy. So that's how they started suggesting the industries and entrepreneurs that in these districts, these are the 3-4 locations or 3-4 villages which are more suitable. And once industries can carry out their own pre-feasibility analysis, saying among those 4 locations, which one is more suitable for them, and they can request the state to allow for the establishment at that locations, and that is done quickly. And once that lands are available, or the industry can go and buy the land, then loans and everything becomes easy, because that's not at all an issue today. Yes, sir.
Yeah. So when we speak about the suitability, this is a very subjective term. Even especially when we speak about Bihar, the geographical term, we are located in the Indo-Gangetic Plains, Tarai region. The upper half of Bihar is located in Tarai region. It is a dynamic landscape, so it is always subjective. That's the reason I think this is why the government has not as such framed any legal framework for a land use land accessibility, suitability assessment. So the best option is what the MOEFCC has equipped right now through the EAC, Expert Appraisal Committee. So they can keep abreast with all the happenings in the state, in the region. So that is the best way to, when we speak about locating an industry in an area or at a particular point.
This can be used as a tool for.
Yes, this is a tool.
This can be used as a tool for.
Yes, this is using multiple factors. This can be assessed, and accordingly a decision can be arrived. Accordingly, a policy can be framed, because this is going to be dynamic always. Yes, policy should also be dynamic. So it can have the dynamic component built into the policy. The government, otherwise. So,
करीब 25 जो है उसमें किया गया था पैरामीटर को।
हाँ, वो डिफरेंट पैरामीटर्स का ओवरले करके।
हाँ, ओवरले अब बना भी था सर, लेकिन क्या हो गया कि यहाँ पूरे एरिया को जो हाईली सेंसिटिव जो है एरिया कंसीडर करते हैं।
That's the reason why I'm saying we are located. Local half of Bihar is in Tarai region.
वो ऐसा नहीं कंसीडर किया।
Tarai region, and flooding is an annual phenomenon. So when we speak about in any sort of measurement, if we speak about suitability, then definitely when it is flooded, people will not come and invest. So most of the industries these days, they are concentrating in, that's the reason why the southern part of Bihar.
So if no more questions are there, let us give a big hand to Kumar. Sir, we are very thankful to you. So, may I request Chairman Sir for it.
Thank you, Professor Ashwini Kumar, for this enlightening lecture. And we are having in Bihar State Pollution Control Board a series of lectures by eminent persons. And we are going to have 2 lectures after this also. In fact, development and environmental conservation, it's a very debatable issue, and how to choose. It is assumed that conservation is against development. If you want to develop, you have to ignore the conservation. And it is largely debated. Some argument was put forward that Western countries have already developed. Now they are talking to us that you go for the environment conservation. But in fact, you cannot sustain your development without conserving the environment. If you want to sustain development to be sustainable manner, you have to conserve the environment. The second point is about the criteria, how to choose them. Because the environmental issue, we don't attach the prices. So it doesn't come into the market point. what happens that earlier when the development fund started, we used to have financial cost benefit analysis, in which we only see the financial part of it. Later, they have switched over to the economic cost benefit analysis, where the whole economy and how the nation, what are the priorities that is to be attached. The whole economy is functioning. The third, when they have seen that in certain people are of different poverty levels, who gets the benefit? So they have attached weightage to the different groups of people having different poverty levels. That is called social cost benefit. Now the time has come that we have to put cost to the environment, degradation, and not having the requisite environment, what will we want to lose? So there is a, if we don't attach any value to the environment benefits, it will happen that we will not able to select the correct project, development project. So in fact, the both development and sustainable development, we cannot ignore the environment as such. The other thing is about the land suitability. Professor Ashwani Kumar has rightly pointed out that you have to select the right quality of land for a particular land use, and both in the terms of economy and both in the terms of environment. Because if you don't ignore the environment, you cannot sustain that development. In Western countries, mostly in America and some, there is a specific body. Even for land use in the categories like agriculture, they define the actual crop also, which crop should be grown in their particular land. And every farmer has to prepare the working plan type of thing, annual working plan, so that they direct that only this crop you can put in this type of land. So this is a very fine tuning. In India also, at least for industry, especially polluting industry and some other industry which is related to, we can assign the value for it. If we use this land for this industry, how much benefit we will get, or how much we are losing in the terms of environment and sustainability. Thank you very much to Professor Ashwani Kumar for enlightening us on this subject, and hoping we will sometimes we will call you for us and use development for Bihar also.
Yeah, sure. Thanks for
Thank you.
thanks to Bihar State Pollution Control Board and all the dignitaries here to listen to my perspective, and hope I think we may able to expand it further. Thank you.
Thank you, sir. और हाँ सर अध्यक्ष महोदय से अनुरोध करना चाहूंगा कि वो अगले लेक्चर का अनाउंसमेंट करना चाहेंगे.
The next in this series of lectures, the next lecture will. Pardon?
No, sir.
live
recording.
The next talk will be by Professor Ghazala Habib, Department of Civil Engineering, IIT Delhi, and the topic is conventional sources apportionment and use of black carbon data for policy decision. Very